Hello, my name is Ricardo Dalagnol. I'm a remote sensing scientist with a focus on tropical forests, ecology, and monitoring. And I'm a researcher at CTrees and part of the team that is now bringing you these new data sets and platform called REDD+AI. So I'm going to start off this video by saying why I think this is important. So I think this is important because it's the first time forest degradation can be mapped and attributed to different drivers. So we can map forest degradation caused by selective logging, fires, and roads in different categories. So I'm going to explain to you a little bit about how the data sets are created, how the data looks like, and how the platform works in this brief 5 to 6 minute video. So come with me. For our first step, we use satellite imagery at 5 meters spatial resolution, the Planet NICFI product. So this is an amazing initiative, bringing imagery from biennial to monthly timescales from 2016 to the present day, and we use all this imagery to map first tree cover loss. This is the complete removal of trees over a given area, and or a clear cut. And we do this at this unique time scale from biennial to monthly. And in the platform currently, you can see data at a annual time scale. But we are planning to improve and showcase later on at more finer time scale as well. So while tree cover loss maps areas that are completely removed of trees, we also map forest degradation, which corresponds to the removal of some trees from the forest or the death of some trees in the forest, caused by some disturbance, which can be human or even climate change and natural, reducing the carbon contents or the biodiversity of these forests. But the area remains a forest. All right, so it's a different process than tree cover loss or deforestation. Um, and in this sense, we are mapping here the three distinct drivers: the selective logging, the forest fires, and the road construction independently, and how they have been affecting these forests. So you can see here on the image on the left how logging affects the forest landscape. It shows patterns of roads and trails, tree fall gaps, and logging decks in the imagery. And you can read a short description of them if you pause the video. So what we want to map here are the areas affected by logging, and not only the pixels in the image that have undergone complete tree loss. This is a clear advantage and a novelty to what we are bringing right now, because we map this entire the boundary of these areas being logged. So how do we do this? We use artificial intelligence AI models that can mimic or reproduce the way that we can see this imagery. So they see the imagery in a similar way that we do, and can create these areas that have been affected and disturbed and degraded by logging. We also map road construction in a similar way, so we are able to only show in the map areas that are roads, so in a separate layer or map. So when you look for a time series, and this example is in Mato Grosso, in Brazil, my home country, and you can see in the left the imagery where it's showing every 6 months or every month right now the logging and the roads being appearing in the landscape, and our model being able to capture that. So these areas could be a forest concession for sustainable development, or also illegal logging. And we cannot make a distinction to them at this point because we only use the satellite imagery, and they are very similar or the same in the image. And local data isn't widely available to really make a distinction. There are some initiatives that do that. For now, we only show what we can see in the imagery. These areas have undergone logging, trees have been removed, and we put that on the map. In a similar way, we also have a layer of forest fire. So it shows forests that are degraded. we try to, as best as possible, to remove other burned areas from our data. So first we map burned area, and then we restrain our data to only show burned forest. So in this sense, we try to remove every deforestation fire or non-forest fire, remaining only forest fire. This example is over the Santarém region, close to Tapajós in Pará, Brazil, and huge fires have affected these areas in 2023, as you can see. So this initiative is part of research that Dr. Fabian Wagner, myself, and my team has been doing in the past few years. And we are very happy to now be able to scale this up to the Pantropic. Now you can see some forest concession and logging in the Congo Basin, and also affecting widespread areas in the Southeast Asia, for example, over Malaysia and over Indonesia. And I'm happy to finally be able to reach this pantropical scale. So as I was telling you, we map four distinct layers. We are mapping logging, we are mapping fire, as you can see here, an example over the Pará region, and we also map the road construction. So all in separate layers, these four distinct layers. So when you zoom into the road, it's less stark as it is on zoom out. It shows these tiny roads and even trails inside the forest that the imagery allows us to see. And you can see here statistics about these areas. For example, for logging, you can see them on the map. You can see their extent. You can see their rates over time in different jurisdictions. So we are very happy to bring these data sets now and hope to contribute to reducing emissions of deforestation and degradation across the tropics. I don't want to say these data are perfect, but they bring new information about making these distinctions on forest degradation. And I hope this can be useful for the community to really tackle this huge problem, which is deforestation and degradation over the tropics. So if you have data that can contribute us to improve our data sets, we are very open to collaborate. And I'm very eager to also improve these data sets for next versions. So I hope you make a good use of the platform and data to make impact. And thank you. See you soon.